Very good morning to all of you. Today I am going to present something called namos. This is actually a device manager for a given OpenStack deployment. So let's see what is namos. So today's agenda is like what is the role of a device manager in a given operating system, and how the namos is playing the device manager role for a OpenStack. And end we will see the demo. Okay, as we all know, like any operating system is, so you will have the hardware, on top of that you will have the device drivers, then kernel, and at the top you will have the user space. So take an example of like a Microsoft Windows operating system. So you will have the computer. Under the computer you will have the type of services it provides. For each type of services it gives what are the devices it is attached to, and each device it will give you like what is the driver it is using it, and whether the device are up or down, whether you can enable or disable. These many features any given device manager provides. So this is the computer, the top level computer hardware. So you have the hierarchy of types of service it provides. For each type of service it gives what are the devices attached to or connected to. For each device it will give you the drivers which is using it for connecting to the device and operating on it. So it will give the details about the driver, and it will give the details about the device it is using it, and finally it gives the status for the device, as well as it gives actions for enabling or disabling, maybe for a maintenance purpose. So here is the summary what we have seen just now. Okay, let us see why it is needed for the OpenStack. So all we know that OpenStack is a distributed cloud operating system. So if you look at it in the similar model, so in the place of hardware we have distributed a data center where you will have storage, network and compute, and on top of that you will be using device drivers. So each of the OpenStack service will have its own device drivers for connecting to those respective devices, and on top of that we will have OpenStack services, and finally the cloud application is the one, or the user is the one it's going to make use of it. So it's almost a similar model. So but it is distributed in nature. So what that means, so in a given region, like whenever we are deploying a OpenStack in a given data center, we will separate into the regions. So in a given region you will have a different data center devices like hypervisors, storage devices, network switches, routers, etc., and they are consumed by multiple OpenStack services like Nova, Cinder, Neutron, etc., and these services are getting deployed across various nodes. We call it as controller node, compute node, network node, etc. So if you look at here, there is a like a relation among them, like a service. If you look at the service, it is getting deployed on a given node for a given service, so given device. If you look at the device, it would have connected to multiple services on a different nodes. If you look at the node, it will be installed with the different services which are connected to different services, different devices. So there is a triangle relations among them. So in other words, we have three perspectives, one from the device side. So the moment say the device side, say device A is consumed by the service A which is on the node X and service B on node Y. For example, VMware ESX cluster is consumed by the multiple Nova computes which is deployed in the Nova compute node, VMware data store which can be consumed in the Nova compute in the compute node, Cinder volume in the storage node. Similarly for the network switches, so it will be consumed in the network node where the network agents are installed. Similarly, it will be consumed in the compute node for making the underlying connections. Same from the service perspective. So The moment a service, it contains of different components. We will just see like what are those. So take a Nova service. It will have a main thing as Nova Compute is a backend service. So that service is connected to a device called say ESX cluster, and it is deployed on a node called say compute node. So as I told earlier, there is a relations among these three pieces: node, device, and service. Similarly for the node. So the controller node, for example, is deployed with the Nova API, which is consuming the Nova DB and the RabbitMQ. So what namos consider them as a device. Anything which is consumed from the data center in the OpenStack, it is called device in namos. So we have seen there are three perspectives, one from the service, one from the node, and another from the device. So namos is brought into the OpenStack to provide these perspectives, but for the given region. So it provides a RESTful interface where you can say these are the list of devices I am using it in the OpenStack, and these are the devices which is deployed in a given node, and these are the services so far I have deployed for a given OpenStack deployment. So all are represented in the RESTful format. So as a developer or a user, you can operate them. Okay. The moment we say service, service contains of service components, and each component will contain of service workers, and each worker will be loaded with a given device driver. What that means? For example, take an example of Nova service. So Nova service will have different components like Nova Compute, Nova API, Nova Scheduler, etc. Take example of Nova Compute. It will have multiple workers. So each workers will be loaded with different device drivers. For example, one will be loaded with say ESX driver. Another can be also loaded with a different compute driver which we don't practice. But if you take a Cinder volume, we can load different backends. So each backend will be considered one Cinder volume. Each Cinder volume can have multiple workers. Say one Cinder volume will have 10 workers, and each worker will be loaded with different drivers. One can be a 3PAR, and one can be a LHN, etc. So that is a service side part. So when we look at the device side, so device usually have endpoints where the OpenStack will consume the device through the endpoints. We can call it as like through the iSCSI interface or the FC interface, etc. And each device will have a given a device driver class. For example, take an example of VMware vCenter. So it will have a different driver classes. If you go to the Nova, it will have a compute driver. If you go to the Cinder, it will have a Cinder storage driver. If you go to the Newton side, it will have the network switch driver. So what I am trying to insist here is one device will have a different driver classes for serving into different services. As I said earlier, in namos, this database and the message queues are modeled as a device, and node is represented as the service node. So if you collectively look at, this is the data model where you have service, device, node, and the region. So the given region is deployed with multiple services, and each service have connected to multiple devices, and each node is deployed with different services which are connected to different devices. So as we saw earlier, those three perspectives is captured in this data model. Okay. So namos is like a device manager for OpenStack, so it would be very useful for the operator. At the same time, it's very much useful for the developer to develop any features which is depends on the given device, or if you want to bring out any features based on the given service or the node. Take an example of a device. So today, say we want to give something called tenancy at the device level. Say for example, for a given tenant A or a user B, whenever he made a request, he needs to be the request should be served from the given device, say given hypervisor or a given storage node. based on the different SLA. So if you want to achieve this kind of features, today it is not possible. The reason behind, the device is not represented in the RESTful format anywhere in any of the services, because namos gives the RESTful interface for the device, so you can bring out any feature on top of it. See, today it just gives the representation for the device manager, where you can go and browse hierarchy of like what are the devices are there, what are the services are there, how it's got deployed on what node, etc. But tomorrow we can enhance this for bringing like active device management. We can enable or disable a device, install or uninstall your drivers for a given device, etc. And say it can be used for even a change reflector. What I mean is, like say in a given big deployment, one node is going down or a device is going down. So what is the consequence of those changes? So which are the services will get affected? So when the service is going down, which are the device going to lose its functionality? So all these things can be captured. And so what I am planning now is like launch this project in the Stackforce, and I like to work with different services team in order to bring, like whenever their device driver is getting loaded in the respective services, it will connect to the namos and will update the device information actively. These are the details about what I have done so far under the wiki information. So let us go to the demo. Okay, so this gives the REST interface provided for the provided by the namos. So what we are seeing in the screen is giving the complete picture of the given OpenStack deployment. So you will have a region. Under the regions you will have a list of regions, and each region is given with services deployed in that region, and host, and then devices. So let us see them as this is a JSON view, and let us see it in the pictorial view. Okay. So in a given region, you select the region. Once you select the region, you can browse among these three perspectives: service, devices, and host. So currently I am running this namos on a given DevStack deployment. So far I am having these services, and say take an example of Cinder service. So it has so many components, and each component is deployed on a given host, and what are the workers it contains. So all these informations are captured here. So if you go to the device, it will give other two ends, like which service it belongs to, and what is the device endpoints it is consuming, what is the device driver it is loaded with, and which node it is connected with. Similarly for the host, because it's a DevStack, currently you are seeing only one host. So under the host, you are seeing all the services getting listed here. So finally, it brings together all the like data center view, and then OpenStack service view, and the host where it is getting deployed. All together it is connecting and bringing the perspective among them. So that is the main objective of the namos. Thank you. Like any questions I would like to take. Thank you very much.